another video. This time around, we want to multiply two given numbers using the intersections of horizontal and vertical lines. So what we're going to do here is to take an example and see how we go by it. Right. So making use of an example, 121 multiplying 23. Now what we do here is to ensure that we represent 121 with lines, be it horizontal or vertical. So let's try to use any of them. Maybe let's go for vertical lines. So based on the numbers found in each of the place value that we have three place value here. We have ones, tens, and hundreds. So if you are starting the placement, you can start from any other side. So starting from right to left, which means one has one as a number there. So one bar represents ones. We come to tens and find two bars. Then we go to the hundreds and find one bar. So since 1 to 1 has represented with the vertical lines, the option left is to represent 23 with the horizontal lines. Good. So 23 with the horizontal lines. First, remember two lines for tens, then three lines for ones. Good. Now at this point is where we can do the counting. Now by doing the count, you have to consider what we call the diagonal relationship or diagonal attraction between the point of intersections. Now in identifying the point of intersection, remember what we mean by intersection is where the horizontal and the vertical lines meet. But in counting to get your answer, we need to identify whether or not one has a relationship diagonally with any other. Good. So if you look at it critically, you realize that this point here, or this diagonal area here, this point of intersection has no relationship with any other point because diagonally there is none facing it. Let's move on. And when we get to this end, you realize that there is, because this point has a diagonal relationship with this point. Let's forge on. When we continue, here has a diagonal relationship with this point because you look at it diagonally, they relate. Then this point also has no relationship with any other point. So the next time we are left to say it is to count. So in counting, we can see that from this end, we can count here from right to left. How many intersections we have here? 1, 2, 3 points of intersection, right? 3. Then let's go to this end. Remember, we have relations, so we count all of them. Remember, 6 intersections here. 1, 2, 3, 4, 5, 6, 7, and 8. So this is 8. Sorry. So 8. This also has a relationship with this one. So 3 intersections plus 4 intersections giving us 7. Then here we have only 2 intersections, so we write it as 2. Good. Now, in order for us to confirm what we have been doing so far, let's check it using the partial product. Partial product here, 3 by 1 give us 3. 3 by 2 give us 6. Sorry, 6. 3 by 1 will give us 3. 2 by 1 will give us 2. 2 by 2 will give us 4. Sorry. 2 by 2 will give us 4. Then 2 by 1 also give us 2. And we sum what we have here. So 3 and then 6 and 2 give us 8. 3 and 4 give us 7. And 2 and 0 give us 2. So if you trust this approach here, then we should also trust this approach here. Well, that's all for now. See you again, and it's bye for now.